So Tammy is going to share with us our new LASSO-O software capability. So this is something that you all are the first to hear about it in details. This is pretty exciting. We'll be updating the tech doc with all this information in the next couple months. This is something we're really excited about. So take it over, Tammy.
Okay. Hi, everyone. Can you see my screen?
Yes.
Okay, great. So my name is Tammy Fairless, and I'll be presenting part 3 on the LASSO-O workflow software. The first thing I'd like to do is acknowledge Karina Lansing's work that has made this part of the tutorial possible. The capability I'll present, which is to make the LASSO software available for modelers to use on their own simulations, would not be possible without her work. I'd also like to acknowledge Krista Gostad for her significant help as well. Okay, so during this part of the tutorial, I'll first present an introduction to LASSO-O in a container. Then I'll give you insight into what goes on inside the container, so it's not just a black box. This is this technology that will allow you to process your own simulations the same way LASSO does. I'll tell you what you need to give to the container, what you get out of the container, and I'll show you how to run it and how to plot your results. Okay, so what is LASSO-O? Everything that Andy was showing you and that Bill was showing you, LASSO-O combines a lot of that stuff. So it's the operationalization of the LASSO workflow from the point of the WRF LES output through to the model evaluation components of the LASSO bundles. As you can see in the diagram that I have there, the workflow includes post-processing of model output there in the pink box, processing of observational data, all the blue, and then those two are brought together in what we call blending, and which is the green, which only refers to the fact that Bill and Andy have both mentioned that the model and the observational variables, which were made comparable to one another in the other sections, are stored side by side in the same files. So this and that fact helps to make evaluation and comparison very straightforward. So in each one of those colored rectangles that you see in this flowchart, they represent an individual process that's packaged as an RPM or a binary, and that's what makes the use of this container technology possible. So what is a container? A container is software packaged into a standardized unit that includes all of the software dependencies required to run the code inside the container. So you don't have to compile any code. This means it's easy to ship the container and it's easy to deploy it. And for the user, it's easy to make reproducible results from one computing environment to another. You may have heard of the common container platforms, which are Docker, Singularity, and Shifter. So we've taken the part of the LASSO-O workflow there enclosed in black and put it into a container. We've chosen the parts of the workflow, the processes and the data that are necessary to produce LASSO bundle data. And here's the great part, from non-LASSO WRF simulation input. So what I'm referring to here is that users can evaluate their own WRF LES simulations directly against the observations used by LASSO. Compare their simulations with the LASSO simulations, compute the same types of variables and skill scores as LASSO, and even develop new skill scores. So zooming in on the components of the LASSO-O container, I'll walk you through the workflow. First, the required WRF output variables are ingested into an ARM compliant form. So if you're working with a different model, like SAM, for instance, the model output would need to be converted into a form that the WRF ingest could handle, or a new ingest could be written for SAM. For the purposes of this tutorial, we'll just assume you've used the LASSO WRF model. The next part of the workflow takes the model data and computes the observation comparable variables at the native model time resolution. From there, the next process simply produces hourly averages of 1D time variables like total cloud fraction, liquid water path, LCL, things like that. The next process tackles production of the 2D time height model cloud fraction, and it makes that mask of the cloud fraction that Andy had shown to compare the model and the observations. The results of that are at the model's time and vertical level resolution. After that, we take the hourly 1D model variables and the hourly 1D observational variables, and we put them into a single file. And finally, skill scores are computed. So that's what's going on inside the container. As far as input to the container goes, the container itself provides all the required observational input. The data, I've circled the data streams there on the diagram. So you don't have to go and get any observational data to feed it. It has it all within it. The only data that the user needs to provide is the WRF LESS raw output, the WRF out and WRF stat files that Bill talked about. And the output of the container is all of those green boxes in the diagram. Those are, the important part of that is that those are the contents of the LASSO diag conf obs mod tar bundle that Andy talked about. So we provide that for all of the different, ensembles that we have processed, but you can produce that for your own simulation. Okay, so again, the only thing you need is your WRF output. But I do want to say a few things about that. I want to emphasize that, let's see, we have this capability for case dates during 2017, 2018, and 2019. Your simulations must be for the same times and durations as that of the LASSO simulations. The LASSO simulations have some extra global attributes, but these are not required for user provided input. The container can handle whatever horizontal grid spacing, domain size, number of levels, and time resolution that you provide. So now let's take a quick look at what you get out of the container. You'll get LASSO mod, which is all the 1D profile and like time XY variables that LASSO-O requires. So all of the stuff that you've pulled out of the WRF raw output, that's the first place that goes after the ingest is here in LASSO mod. After that, you'll get the data, let's see, to create hourly time series, like in that plot. You get the data to create plots like those of the cloud fraction from the model, and in addition to the mask. And you get the skill scores for your models. Okay, so I'm going to talk a little bit now about, I'm going to tell you how to do this. So we'll go over what it takes to use the LASSO-O container. You'll likely want to run the container from somewhere you can access your WRF output, like an HPC cluster, right? Because you don't want to be moving that around. The computer you use must be able to deploy one of the container platforms that we offer compatibility with: Docker, Singularity, or Shifter. So Docker is probably something you would use on like your laptop, and that might only be good for, maybe a test. It'll take longer. You probably don't want to run it on all of your files. If you're going to be on an HPC, you're going to use Singularity or Shifter. And you can start by going to the GitLab site that's listed there. We can, maybe somebody can put it in the chat, or we could, it's also in the README, the tutorial README. Let's see, so the first thing is just go, wherever you're going to be on your HPC cluster, clone the repository and review the instructions in the README. They're really good instructions. I could do this pretty easily. So after Karina set it up, it wasn't too bad at all. The first thing you do is set up your container runtime environment, which sounds a lot harder than it is. There are 3 container runtime specific READMEs. Personally, I've tried Singularity so far because that's what was available to me on the cluster that I was working on. For Singularity, all I needed to do was just make sure the right version, 3.6 plus was available, and the module was loaded. The other READMEs for Shifter and Docker are similar in that there's not too much that the user needs to do. Next, you'll make the simulation data available to the container. After you clone the repo, you'll find a data/inputs subdirectory, and this is where you can place or link your WRF stat and WRF out files. The easiest thing to do to explain this is to take a look at the listing on the slide there. You can see that the WRF out files for one simulation have been put into that directory, SGP WRF out 3 C1.00. And the WRF stat file has been placed into a similarly named directory. The 3 is just to identify the simulation. It's just an ID number. You can put in, you can do this, you could process 10 simulations at a time. So simulation ID number 1 through 10. So far, all we've done is basically make sure we have the right runtime environment and then place our data into the right directory. The next thing to do is to edit a configuration file, config.yaml. All you have to do is fill out in there the date that you're processing and the container runtime you're using either Singularity or Shifter if you're on an HPC. And then you can run the container. So Karina has designed this and set it up really nicely. You can see that the steps you need to accomplish are very limited. But the specific run command that you use in this step of running will likely depend on the container runtime that you use and on the scheduler, like Slurm or PBS. Let's see, I've had success with Singularity and PBS on a cluster, very, very easy to do. We've had some trouble so far mounting the container image when we've tried to use Shifter on NERSC, but we're actively pursuing that and testing as we speak, and we'll update the READMEs with any and all information we have on system-specific information like that. The LASSO forum will likely be a good place to glean from others' experience of running on the various available clusters, but we'll try to keep the documentation on the repo up to date as well. So you'll find that for a single simulation with 226 levels, a domain size of 14.4 kilometers, and a grid spacing of 100 meters, it takes about an hour to run. And after your container runs, you'll find the following in your data directory. So if you look here, we have data inputs. This was the input. Just the two here, we're just doing one simulation. We've picked number 4 to call, we're calling it, simulation ID number 4. Here's our WRF out and our WRF stat files. In the outputs, you have some logs that are basically logs for each one of the processes that run, just in case anything goes wrong. But this is the exact code that all of LASSO has been processed with. So, or at least 2017, 2018, and 2019. Then you'll have the input that was contained in the container will now be accessible to you. And here's all the output from the container for your simulation ID number 4. And these are the things that Andy talked about, the skill scores, the files with the co-located observation and model time series. You'll have all of that after you run the container. So included in the repository that you cloned, there's a notebooks directory. Inside that directory, you'll find instructions in a README to help you create the required conda environment for Python notebooks, Jupyter notebooks, from which you can plot all of this data. Let's see, the most unusual package that we're loading is CDAT, which we use because it has a nice Taylor diagram routine. We also load Xarray and netcdf4 because Xarray doesn't really like the time resolved height bins. So the available notebooks include the following kinds of plots. So plot 1D, allows you to plot the time series, Taylor diagrams, and heat maps. Plot cloud fraction helps you, allows you to plot the observational cloud fraction, the model cloud fraction, as well as the mask that we've talked about a couple of times. You can plot the profiles for the soundings versus the model. Here we have theta, theta E, temperature, and water vapor mixing ratio. And you can plot your skill scores. So I know I kind of went through that fast, but in summary, this LASSO-O in a container gives you the ability to process your own WRF LAS models in the same way LASSO simulations are processed, which really streamlines model evaluation. LASSO-O in a container and all the documentation is available at that repository. And remember, it only requires a computing platform with Docker, Singularity, or Shifter, and access to your LASSO WRF raw output. And that's what I have. And I'm happy to take questions.
Thanks, Tammy. I think one of the last questions is a good one to start with. Yunyan was asking about if she wanted to use a different model, what all she need to do is essentially reproduce the input formats in terms of variable names and things like that, or how would she approach that?
So to use LASSO, we just need to rewrite. That's exactly right. Yep, exactly. So in order, you have to rewrite your LES model output to match exactly the format of the WRF output, correct?
Yeah, so Yunyan, you might be familiar with some of ARM's processes. Technically, we're doing what ARM calls an ingest on the WRF out files to make them compatible to go into the workflow process, essentially. But you could either mimic WRF or rewrite that ingest.
Right.
So maybe it will be helpful that give us a list of the WRF output variables that goes into your evaluation. I mean, generate the skill score, so we can exactly match those from, for example, from SEMruns or other LES. Is it possible?
Absolutely. Sure, we can, because we don't use everything from the WRF output, so I could identify the variables that we use, and yeah, and then you would just have to pull that information out of whatever model you're using and put it in same variable names, things like that. Yeah, absolutely.
Yeah, we're still working through the documentation for all of this, so those are some of the details we can consider including. Thanks. See here.
You're working, yeah. So it's we are working to make the container work on NERSC actively. Yep.
Yeah, and there was one question about possibility of using LASSO-O for other locations. I think at this point it's not really designed to easily move around because they're so tied to the central facility observation suite. Do you have any comments on that, Tammy?
Yeah, tied to the central facility and also tied to the shallow cumulus, you know, scheme or scenario. So I think it would require some work depending upon the instrumentation at the particular location, and again, you know, probably the easiest thing to do, you know, if you were going to do that, you'd want to do it for shallow cumulus again.
Yeah, we're tied to that scenario in this case. One advantage of this LASSO-O, now that the software is out there, if users have specific analyses they want to do with the available observations, they could code that up and then cross compare that even with the existing LASSO simulation if they wanted to, because we haven't thought of everything. We just kind of done some basics that we think is useful, but there's always research that we haven't thought of that you might want to apply this for. Let's see, a little more comments popped up at the bottom here. Oh, it's just thanks. So, There might be some questions I've missed that have flashed by. So if there's any we haven't addressed, feel free to raise your hand or to speak up. We have a few minutes before we go to the closing. So Verinder is asking about our upcoming ENA scenario and what kind of cloud conditions we're thinking about for that. We haven't gotten into the specifics a whole lot yet, but I think one of the things we can comment on when we talked about what would we want to study at the ENA location in terms of a LASSO scenario, precipitation characteristics, and particularly the kind of process understanding of drizzle and why it happens so often is something that really came to the surface. So we'll probably be targeting those types of conditions when we go through the case selection process in our configurations.
Yeah, and I'll just add that this also implicitly means that we're going to be looking at both open and closed cell cases.
Yeah. Trying to understand from that variability. Yeah, we're pretty excited about these new scenarios coming up and broadening the library for people. We've learned a lot with the shallow convection. In some sense, shallow convection is the easiest modeling approach to start with. That's kind of laid the groundwork for the getting LASSO out there and some of the tools developed and working with ARM infrastructure to learn how do we share this data easily and things like that. So now we're going to build on that. And the next scenario is going to be much computationally more expensive. We hope very powerful for users as well. So. Okay, I don't see any other questions popping up at this point. Feel free to raise hands and things. I'm going to take over the screen if you can take yours down, Tammy. Where's the share button here? So I've just got a couple of closing slides here. And then we'll take any remaining questions at the end. So for the epilogue now, some just generic thoughts here. One of the things we wanted to share with folks is that ARM does make available some computing resources if that would be of use for your research and working with LASSO. We have a cluster that ARM calls Cumulus. We've been using to do the LASSO production work. And it's actually going through a refresh just this past several weeks. ARM received some new compute nodes that we're calling it phase 1 for Cumulus 2. And that'll be further supplemented later this year. And by the end of the year, we expect to have about another 16,000 cores available that we're going to be using for the cacti simulations and for the ENA simulations next year. But essentially, if you need access to a lot of the LASSO data at one point and your home institution isn't a place where you can easily work with that much data, we do have the LASSO data pre-staged on Cumulus, so you can ask to get access and work with it there. Or if you want to rerun some analyses on those warp outs that we have available, things like that, you can do that on this Cumulus cluster. You just go to this HTTP link at the bottom here, and that'll take you to the ARM's website where you can request those computing resources. So that's something that not everybody's aware of. The other thing I really wanted to point out is that it takes a lot of people to do a product like LASSO, and we're really appreciative to the whole team that's worked together to make this happen. You've seen some of the people that have worked with it today, but there's so many other people involved. Hung Zhao and Satoshi Endo are modeler experts that have been doing a lot of the LES runs and the forcing generation for us. We have Zhijin Li and his previous postdoc Xiaoping Cheng, who really helped out getting the MSDA data simulation going and set up for us. And there's so much that has to go in on the back end as well. Just people developing the websites for us and the database work for things like the metadata table and all the ARM infrastructure just to take all these observations. It's a huge list of people that there's no way to list them all. When we start thinking about how many people are involved in this, and we're really appreciative of all of those folks. And particularly just for today, even the communications team has played a big role in helping get this tutorial going so that all of you can learn more about LASSO. So Michelle, Stacy, and Katie have all been really helpful with that. So this is the last slide I just wanted to leave up in closing. It's basically the same one that I had at the end of the prologue. If you want more information, there's a lot of ways to get that, and those are a lot of the links here. Andy's going to share the Google folder link again in case you missed it to download these slides, as well as I've got like a README file that just lists all the relevant links for LASSO. So you can download that if you were interested. At some point, we'll get a permanent location where all these files will be housed. So we'll share that with you via email. Right now, it's just in a Google folder in my Google account, but we'll get it in a formal ARM location going forward. And then finally, we ask that you complete a survey just to give us a little information on where you're from, as well as what you thought about today's presentations. You'll get an email with this link as well, so you don't necessarily have to write it down right now. But we encourage you to fill that out because that'll be helpful for us if we ever give this tutorial again, as well as ways we might need to enhance our documentation and things like that. So thank you for coming today. We really appreciate it. I didn't go through the participant list, but we had people signed up from at least 10 different countries. So that's pretty exciting. I think the farthest west of the United States was Australia. We had some people in Korea, and going east, we had people in Germany and France, as well down south in Argentina and Brazil signed up. So it's pretty exciting to see such a wide range of interest in the LASSO products. So thanks for coming today. So, and if you have any other questions, Andy and I and Tammy, we can all stay on as long as necessary. So thanks a lot.